Hello class, how's it going? I hope you're doing great. I'm gonna show you. I'm gonna show you how to conclude this. Well, let me. Okay, here we go. How to conclude this problem, guys? This one, the problem that we were working on. Remember, in the previous 2 or 3 lessons, we have been talking about this idea of having a population of students in CDEP and then taking a sample. In this case, in order to make it much simpler, I'm just gonna go for 5 students. Previously it was 15, but for simplicity, I'm just gonna take 5. This makes no difference in reality in the way this problem is handled. Okay, and suppose that the observations that I made for height and weight are the following. Okay, for these 5 students, they are in meters. These are in kilograms. Just take a brief look at these quantities, get a feeling for the correlation of this. Look at the minimum values, the maximum values, and the behavior as they increase. Okay, and why am I putting here x and y? Okay, that's because, guys, your calculator mostly works with the notion that x is the independent variable and y is the dependent variable. In this case, for the purpose, if you remember, I put h, the height, in the horizontal axis, right, and weight in the vertical axis, and it's understood, or it's tradition to understand this the horizontal axis as the independent variable and the vertical axis as the dependent. So I'm gonna make that consideration. For us, the height is the quote-unquote x, or the independent variable, and the weight is the quote-unquote y, or the dependent variable. So let's perform all the following. We're going to do all of this by making use of the TI. We're not going to do anything by hand. It's purely software generating. Okay, so let's start. They want me to draw a scatter diagram for this bivariate data. Remember that each of these rows represent uh, each of these rows represent a point in my data set, right? 1 point, 2 points, 3, 4, and 5 points in my data set. So let's draw a scatter diagram by using your calculator. How do we start? We start in the following way. We go home, we click on this spreadsheet, and something very similar to Excel is going to appear, right? This is what is known as a spreadsheet. Okay, so I'm going to put all my heights in this column A and all my weights in this column B. Okay, remember, height is the independent, weight is the dependent. Okay, and in order to do this, guys, you first have to label the columns. Okay, what is this column for? It's for the height. I'm going to label it H. This column is for the weight, so I'm going to call it W for weight. That is the first thing that must be done always. Always, it's mandatory to label your columns. Okay, and then, oh, and by the way, I was forgetting. I'm using obviously the computer software, but I'm gonna try to tell you how to do it by using the keys in the calculator. So now you are positioned in this cell, and just enter the values, right? 1.4, 1.5, etc. up until 1.5, 1.8 in jumps of 10 centimeters. So how do we do that? Well, this is quite simple. 1.4, down click, 1.5, down click, etc. Right? I'm gonna do it with my keyboard now that you know. Okay, and then I can move around the cells with the keys. I go up, and then I input the weights: 40, 52, 65. 69 and 80. Okay, there it is. That is my whole data input. I'm done with the inputting of data. Okay, what's next? Remember, what are we trying to do? We're trying to draw a scatter diagram, diagrama de dispersión. Okay, what do we do next? What we're gonna do is this. You're gonna go back to home. You're gonna click on this in order to make sure that you're working with the document 1.1, which is the one you're working on. Go back to home and then click on this histogram icon. Okay, there you go. Then some point, the 5 points that are going to be in our scatter diagram are going to appear at random here. You're not going to see any type of pattern or anything. Don't worry, don't worry. What is the next thing to do? If you notice here, in here we have click para agregar variable and the same on the vertical axis. So remember, what variable are we going to use for the horizontal axis? We're going to use the height. And how do I get this to be the height? What you do is this. You go to the tab key, I'm sorry. Click on it. Okay. And then select the height. It's already selected. So just press enter. Okay. And then how I choose the weight for the vertical axis. Once again, I click on tab. This is going to appear. Down click. Select. And that is the scatter diagram. Okay. That's it. This is what you're going to be ending up with in a different document, 1.2. Remember, in the previous document, we had only the spreadsheet with the data points on my data set. Okay. How can you jump from documents? How can you jump or switch between documents in your TI? What you do is this. Can you see this? Do you see this icon here? This blue icon. Okay, you're gonna press Control. You're gonna press arrow up, and then that's how you can jump between documents. This is the document 1.1. This is the document 1.2. So by clicking on this right arrow or the left arrow, you can choose that one. You see? And if I want to go to the previous one, I can do this. Okay. So that's it. That's my scatter diagram. We can see a clear linear trend, right? It's linear. There seems to be a very strong correlation, positive correlation between the height and the weight of these 5 students. Perfect. And that actually achieves the first task. Second, or letter B, calculate the correlation coefficient and interpret such number. Okay, what is the correlation coefficient? The correlation coefficient, guys, is, and by the way, it's represented by R. Let me put that down. R. Okay, this is the way we represent the correlation coefficient. And it's just a number. It's a number that quantifies what is the strength of the correlation between this variable, between the variable height and the variable weight. Okay, because at this point, all we can say by just looking at this scatter diagram is that there is quote unquote correlation, but just like that, it's just a vague idea. Now that when we find this coefficient, this actually quantifies such strength. And in the book, I don't know if you have seen, there's a table in which they tell you how to interpret in, let's say, normal language, the correlation coefficient. Between 0 and 0.25, we consider the correlation to be very weak. Between 0.25 and 0.5, a weak correlation, and so on. A strong correlation would be something from 0.75 to 1, which would look like this. Strong positive correlation. And the same ideas, the same things, but negative, right? Like instead of these values, we have between well, between 0 and minus 0.25. That would be very weak, negative correlation, etc. Okay, so let's actually, is this thing recording? Just making sure. Let's actually find the correlation coefficient. So let's go to the previous document, 1.1. And what I'm gonna do, guys, is I'm gonna perform the basics. I'm gonna find the basics of bivariate data for this data set. Okay, this is a data set of bivariate data, and I want to find some things among which is the correlation coefficient. What do? You go to menu, right arrow, no, down arrow, statistics, right arrow, cálculos estadísticos, enter, and then we have this menu. We have number one, statistics of one variable or univariate analysis, and this is bivariate analysis. This is the one that I want. I click on it. Okay, and then we have this. All the stuff that you're going to be using is this, the first row and the second row. Okay, what do? Right arrow. Then my two variables are going to appear, height and weight. Down arrow, I select height, click. Down arrow, right arrow, down, weight. Okay, and then I just press the down arrow until I reach OK. I accept, and then this is going to appear to the side of your data set. Okay, and it says título y estadísticas de dos variables. Okay, what do we have in here, guys? We have many information. For example, what is this? This is the average of your x variable. What is your x variable for us? It's the height. What is that? What is the average height? 1.6. Can you see? What is the sum of all the x variables? In other words, what is the sum of all the heights? 8 meters. And then, and the same for several other types of numerical quantities that we may or may not take a look at later. The one that is interesting for us right now, oh, by the way, n, what is n? The number of data points that you have, which is 5 observations. The average for the y variable, which is the average of the weight, 61.2 kilograms. You see? So we scroll down, and this is the one we wanted. R, which is a correlation coefficient, and it's pretty strong, 0.998. That is classified as strong. Almost perfect, indeed. Okay, so that's it. That's my correlation coefficient, and that deals with this one. Okay, we calculated it using the TI, and we interpreted it. Which is there's a very strong correlation between these two variables, the height and the weight for this set of people. Okay, let's continue. Letter C, find the line of best fit using linear regression. Okay, at this moment I have explained to you what this is with a lot of precision. We have been talking about this idea of the line of best fit for 2 or 3 classes, and you must understand what it means at a conceptual level, at an intuitive level, and also with precision, right? Because we defined how to get this line of best fit. Okay, linear regression, guys, is actually the method that we're trying to use. You know, when I told you that the line of best fit is a line that minimizes the errors. Do you remember that? The errors between each point and the prediction given by the line. I hope you remember that. What we are doing is known as linear regression. So don't let this word scare you. Okay, this is a method we use Although at this moment I hadn't mentioned it. This is the method we use in order to find the line of best fit. Obviously, with the TI, you're not gonna be doing any of this by hand. It's automatic, right? That's the point of software. So let's find this line, the line of best fit for this particular scatter diagram. Okay, so we have it in here, and what do? We do this. You go to menu, you go to option number 4, analizar, regresión, and the first option, mostrar lineal, show linear, mx plus b. Click on this, and this is the line of best fit that the TI is calculating using linear regression. This is it. And this is the characteristics of this line. Y equals 97. This point is a decimal point. This point is times 97 times x plus this coefficient of minus 94. And once again, this point is a decimal. You see, so you gotta be cautious in how you interpret all of these things, because this may look weird, a little weird, right? And you might be asking, why is the TI not giving me plus minus times minus and then just minus 94 instead of this? That's the way it is. So you have to take care into understanding how this thing is gonna be displaying numbers for you. If you notice, guys, another thing that you should notice is that, once again, I told you, the TI works with these two variables, y and x. Even though you label this as h and this is as weight, okay? If you notice in here, this is not w and this is not h. So once again, be aware of how the TI works. X is the horizontal variable, y is the vertical variable. Okay, so this is a line of best fit, and this is its equation. And that's actually what we wanted. When we say when somebody asks you find the line of best fit, this is what they're asking you guys, the equation of such line, the equation. And if you remember, this is the slope intercept form of the equation, right? Y equals m times x plus b. M is 97, that is the slope of this line, and minus 94 is the y-intercept of this line. So that's it, and that takes care of this letter C. Now, let's do D. Use the line of best fit, the one we previously obtained, this one, to predict the weight of someone whose height is 1.55. This is known as interpolation. Okay, what is interpolation, guys? Interpolation is this. If you notice, we have a person whose height is this much, 1.55 meters, which is about here. This is 1.5 meters, 1.6 meters, 1.5. And for that height, we don't have a data point. So we need the line to predict. Okay, it's gonna be about, what do you think? It's gonna be, okay, and then go this way. About 67. Can you see? Go up, go left. 55, 3, yeah, about 6, 50, 50, 45, 50, 55, yeah, about 57, give or take. Okay, so how do we use it to predict such weight? Use the line of best fit. All you need to do is this: introduce the height, which is the x, introduce this height, 1.55, in here. So you're going to be multiplying 97 times 1.55 minus 94, and you're going to be getting the weight, the respective weight as a prediction. So let's do that here in the calculator itself. Let's go home. Let's go to the arithmetic icon. Another document is created, and let's write 97, which is the slope. Do you remember? And then multiply by the height, and then subtract 94. That's how it is. Enter, and this is the weight, the predicted weight, 56.35 kilograms, just like I told you, more or less, 56. Okay, so that takes care of this one. And why is this known as interpolation? Because what we are doing is trying to predict a value for the weight for a value in the height which is within the range that we were working on. We were working within this range from 1.4, that was our least value for the height, 1.8, that was our greatest value for the height, and we are working with values inside this zone, inside this domain, 1.55. That is called interpolation. Inter from for inside, right? Okay, that is called interpolation, and that is we often say that this is kind of safe. This is a safe prediction to make. Okay, it usually yields good results. When you try to interpolate a value, it often gives you good results in real life. Next, use the line of best fit to predict the weight of someone whose height is, I didn't correct here, sorry, of someone whose height is 1 meter. So it's kind of like a kid, right? Okay, so let's check. This is known as extrapolation. Why? Because we're trying to predict the weight of somebody whose height falls outside the range that we were working on, from 1.4 to 1.8. It's way, way over here to the left, you see? So that is called extrapolation. Extrapolation. Okay, and let's see what we get. Let's go to our document of arithmetic. Let's do the same. I'm using the line of best fit to predict the weight of this small person. And as you can see, look at this. So this line of best fit that I have in here is predicting a weight of 3 kilograms for a person whose height is 1 meter. So as you can see, this is completely disastrous in real life terms, right? I mean, 3 kilograms, I guess that's the weight of a newborn, right? And what is the height of a newborn? About 50 centimeters or something, I guess. I need to check that up. I have no idea. so yeah, right? This is not possible for a person of 1 meter. This is it's just wrong. It's just wrong. So as we can see, when we extrapolate, when we try to make an extrapolation, it's very unsafe. It's very dangerous. Okay, oftentimes it gives you basically ridiculous results. So interpolation, that is safe. You can count on this to make, let's say, good predictions, but extrapolation, you have to be extremely, extremely cautious. Now, I want you to think about why this happened. Why is this line? Why is this line? The line of best fit for these 5 points not giving me a good prediction for the weight of a person whose height is this much. I want you to try to explain it to me in the next lesson. Okay, that's what I want you to do. Like, what's happening? What are we not thinking about? Okay, and finally, in order to conclude this lesson, can we use the previous line of best fit to predict backwards? That is, predict the height if we know the weight of someone. So now we're trying to go backwards, right? In here, remember, we're trying to, what the predictions that we made were predictions for the weight given the height in these two, in this one and in this one. But now the question arises, can we do the opposite? Can we predict the height by considering the weight of a person? Okay, so that would be like I don't know what I did. I don't know how it got erased. Well, never mind. Can we go backwards, right? Let me use my pencil instead. So what was it? It was uh, y equals 97 times x minus 94. And remember, this stands for the weight, this stands for the height. So we input things in here and we get predictions in here, right? And now that last question that I showed you is the opposite. Can I input a value in here in order to predict in here? Let me put that input and prediction, right? Algebraically, you can. Algebraically, if you take a look at this equation, right, then of course you can input some height in here, let's say 1.5 meters, and then you can predict. I mean, you could algebraically speaking, algebraically speaking, you can actually isolate x, which is the weight, and find it, right? But no, you should not do that, guys. Okay, we cannot do this when we're working with these types of lines of best fit. It is important that you don't do that. There is another line in order to do that, such a thing, in order to go backwards. But I'm gonna stop it right there. I'm basically telling you that you cannot predict backwards by using the line of best fit obtained in these first exercises. You can't. You can't. I'm gonna tell you why, and I'm gonna tell you what to do later in the next lesson. In the meantime, I think this is enough. Practice this thing on your own. The same problem, this same problem. Practice it 2, 3, 4 times. Acquire some familiarity with the TI, okay, and do it 2, 3, 4 times. And as homework, I want you to do two similar problems to this one. I want you to do from section 7D. I mean, you're gonna be doing them. You're gonna be doing them all in the end. But what I mean is for next lesson, I want you to do number 6 and number 8. That's what I want you to do. Okay, that's it. Thank you very much, guys. Have an excellent day and a great weekend. A very long weekend because of por el puente. Thank you, guys.